Hello everyone. In this video I'm going to go over some basics on exponentials, both in graphing and then just some basics about the definitions, domain, and so on. So for exponential functions, we have two types of graphs. The one that most people are familiar with is exponential growth, where you start something very small and then eventually goes to infinity. It gets bigger and bigger. The other one is exponential decay, which is just the opposite. It starts out here in quadrant 2 and eventually gets infinitely close to 0 as a horizontal asymptote. Now each one of these, you have a couple points of importance. The main one is right here, and this is the point that you see on the left for my exponential growth. This is the point 0, 1. And you'll find the same point for exponential decay so whether it's growth or decay, the graph goes through that point in particular. Now some of the things you can model with these for exponential growth, things like cell growth, or if you have a bank account, most bank accounts that earn interest will follow exponential growth, especially compound interest. For decay, probably the most common one that I can think of would be radioactive decay. Things like half-life, for example. Now, these are the graphs of the exponential function, and the basic formula looks like this. F of x equals b to the x, or y equals b to the x, however you want to think of it. And the base, as a rule, the base is always never equal to 1 and is greater than 0. That allows us to have the curve that we see. Now from here, this shows us how we can get both the exponential growth and decay function is purely based on the base. When the base is larger than 1, then this is growth, as we saw back here. So so that could be, for example, 2 to the power x, or 5 to the power x, or 1.3 to the power x. These are all growth formulas, or growth functions. For decay, that base must be between 0 and 1. Most people think of it as a fraction. But be careful, because the fraction still has to be less than 1. So for example, 1/2 to the x, or 7/10 to the x are two examples of basic functions of exponential decay. Again, most people think of them as fractions, but just be careful that the fraction itself is less than 1. For example, 3/2 to the x is still considered a growth function. Now what that also means is we have another point that we can plot on our graphs. Either way, whatever the base is, if I have the point at the point 1, or at the x value of 1, we'll just say right here, let's try that again. There we go. So this point is, I'm going to mark it over here, 1, B. both for the exponential growth and decay. So I'll try to make it here. When x is 1, the y value of our graph is b, whatever the base happens to be.
You have mail.
Now, some other common parts of this. The domain of each of these, whether it's decay or growth, is all reals. The range, now before you get into transformations and translations, reflections, the range stands at, and I'm going to use set Bodo notation, y is greater than 0. Or if you're familiar, using interval notation, our range would be from 0, non-inclusive, to positive infinity. This also means that we have a horizontal asymptote at y equals 0. And these are common both, as I said, to exponential growth and exponential decay. The common domain, the common range, and the common horizontal asymptote. So this is the brief summary of exponentials, both on graphing and domain and range. Hope this was helpful, and have a great day.